Hey guys, so we are back for week 3 of distance learning. We're going to be focusing on negative exponents today, but before we actually get to that, I do want to spend some time just reviewing the stuff that we've done for the last 2 weeks, making sure we're comfortable with that, and then we will move forward. Okay, so I'm going to go through these pretty quickly. If you want, you could always pause this, try these on your own, and then check your answers against mine. I'm not really going to spend too much time explaining. I'm going to try to move through these fairly quickly. So the first one. Same base, so it would be negative 3 to the 10th. We add the exponents. You could just leave your answer like that. For the second one, we have a negative 1 in front of that negative y, so 5 times negative 1, negative 5. Y to the 6th times y to the 1st, same base, add the exponents, y to the 7th. Number 3, same base all 3 times. We have the 2nd, the 1st, and the 12th power, add them up, so it would be z to the 15th. Number 4, 2 to the 3rd is going to be 8. So 8a to the 2nd times 3 squared is 9. 9a to the 5th. 8 times 9 is 72. A to the 2nd times a to the 5th, same base, add the exponents, a to the 7th. Number 5, distribute that 3rd power. So this is going to be 5 times 5, which is 25, times 5, so 5 to the 3rd is 125. A to the 2nd to the 3rd, exponent raised to another exponent, multiply, so a to the 6th. Number 6, distribute that power. 2 to the 3rd we know is 8, x to the 4th to the 3rd, multiply the exponents, so x to the 12th. Okay, number 7, a to the 4th to the 3rd, multiply the exponents, so a to the 12th times 5a to the 7th y. We have same bases, so 5a to the 19th, we add those exponents, y. Number 8, distribute that second power. Remember, negatives go in parentheses. Negative second squared is actually positive 49. So positive 49x squared. Number 9, that squared gets distributed to everything. Again, negative in parentheses. X to the 4th to the 2nd, multiply the exponent, so x to the 8th. Y to the 2nd, negative 3 squared is positive 9. X to the 8th, y to the 2nd. Number 10, be cautious here because there is actually a negative 1 in front of all of those. So those exponents not only go to the a's, but also go to the negative ones in front. Negative 1 to the 3rd, if you put that into your calculator, it'll stay negative 1. So that would be negative, you can put a 1 there or just a negative. A to the 5th to the 3rd, multiply the exponents, so a to the 15th. Times negative 1 to the 4th power is actually going to become positive 1. So then that's just going to go away. A to the 2nd to the 4th becomes a to the 8th. Negative 1 to the 5th is actually going to stay negative. And then a to the 5th. Now, just a little kind of tip for you guys that might be helpful. Whenever you have a negative number and you're raising it to a power, if the power is even, 2, 4, 6, 8, 10, it's always going to become positive. If it's an odd one, 1, 3, 5, 7, 9, it'll stay negative. And you'll see that. When we raise it to the 3rd power, it stayed negative. To the 4th power, it became positive. To the 5th power, it stayed negative. So it's kind of always an easy tip for you guys to use. So then from there, I do have like a negative 1 and a negative 1. Those would become positive. Same basis, so then I add all the exponents. 15 plus 8 is 23, plus 5 is 28. So it would be a to the 28th. Number 11, that negative's out front, so we keep it out front. That squared goes to the 4 and to the x to the 3rd, so negative, and then it's going to be 4 squared is 16, x to the 3rd to the 2nd is x to the 6th times 3x. Negative 16 times 3 is negative 48. That's like an x to the 1st over here, so x to the 6th times x to the 1st. Add the exponents, gives us x to the 7th. Number 12, distribute that 3rd power to the negative 2, to the x, and to the y. Negative 2 to the 3rd, x to the 3rd, y to the 3rd, times negative x squared. So we have negative 8, x to the 3rd, y to the 3rd, times negative x squared. Negative 8 times basically a negative 1. is going to give me positive 8. X to the third times x to the second is x to the fifth, and then y to the third. Last problem here. Two ways you can do this. You can distribute the third power and then distribute the fourth, or you can combine the 3 and the 4 and make this negative 5ab to the second all to the 12th. Either way it would work. If you want to try it both ways, you can. Then we will distribute that. So negative 5 to the 12th times a to the 12th times b to the 24th. I would be totally fine with you leaving it like that. If you want to figure out what negative 5 to the 12th is, go for it, but it is going to be a very big number. Okay, so that was just some review. Obviously, if you have questions during our live session, you can ask me, but I wanted to make sure that we got a little more practice, and I really wanted you to make sure that you understood exactly how to do these. So the new topic we are talking about now is negative exponents. So when I have a base being raised to a negative exponent, what does that really look like? That is the same as taking this and writing it as 1 over a to the first. What I did was, if you think about it, okay, there's like a 1 in the bottom here, okay, and there's a 1 out front there. We just don't write either of those. So whenever you have a negative exponent, you bring that piece down to the bottom. Now, if it's in the bottom, you'd bring it up to the top. You just flip whether it's in the numerator or denominator, depending on where it starts. If it starts in the numerator, it comes to the denominator. If it starts in the denominator, it goes up to the numerator. Okay, so it really just depends on where your negative exponent is. And we're going to work through a bunch of problems like you see under here. It's going to incorporate a lot of the stuff that we've already been doing, but just be cautious of that. And I think as you see more examples, it'll start to make a little more sense. Okay, but it would move to the other spot, and then the exponent would become positive. So this first example, 3 to the negative 4th. I do not like to have negative exponents in my answers. So what I'm going to do is rewrite that. Since it's in the numerator, I'm actually going to bring it down to the denominator. 1 times 3 to the positive 4th. Once you move it, the exponent becomes positive. And then 3 to the 4th, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 1 over 81 would be my final answer. Okay, you can't deal with negative exponents until you make them positive. Number 2, we have 5 times 2 to the negative 3rd. Okay, again, I don't want to have a negative exponent, so I'm going to rewrite that as 1 over 2 to the 3rd. I brought it down into the denominator. Okay, so then that's the same as 5 times 2 to the 3rd is 8, so 1 over 8. Just multiply those, that's like 5 over 1, multiply straight across, so that answer would be 5/8. Now we're getting into a little more trickier ones because now we kind of have variables involved as well. So one thing I want to point out, this negative 3 right here, it stays. You can have negative numbers. You just can't have negative exponents. That is two very different things. I don't want you to think that negative 3 now all of a sudden has to come down to the bottom. The issue we have right now is this y to the negative 3rd and just the a to the negative 6th. The 4 stays where it is. It has nothing to do with the exponent. The only thing that has anything to do with the exponent is the a to the negative 6th. So when I go to simplify this, negative 3 stays where it is. X to the second can stay where it is. But that y to the negative 3rd is going to come down to the bottom. And it's going to become positive. Okay, now let's look down at the bottom. The 4 stays where it is. There's nothing wrong with that being there. But the a to the negative 6, that has to come up top and become positive. Okay, so you see what I'm saying when I say if it's up top, it comes to the bottom. If it's in the bottom, it goes up top. It just depends on where it is. It just flips its position. Okay, and then you would look, is there anything I can combine or simplify? There isn't, so that would be our final answer. You never want to have negative exponents in your answer. Okay, let's go ahead and let's look at number 4. First thing I want to draw your attention to, because this hasn't gone away, 7 over 14, if I just gave you that, you would simplify that to 1/2. It's no different here. Those would still simplify. The only issue we have, x to the 3rd's good, y to the 2nd's good, is just this a to the 8th. So when I go to fix that, I'm going to have, and you don't need to write the 1 up top, you can, x to the 3rd, y to the 2nd, everything's good up top. On the bottom, the 2 stays, but that a to the negative 8th will now come up top and become positive, and that would be your final answer. Okay? Let's look at number 5. There's 2 ways you can do this. I'm going to show you the way that I think is more straightforward since you already know this method. I'm going to distribute that negative second power. So now I'm going to have negative 3 to the negative second, and I'm going to have x to the negative second. What that will then look like is both of those need to come into the denominator because of the negative exponents. So now it's going to be 1 over the 3 stays negative. The number can be negative, it's just the exponent that can't. And then x to the second. So then I'm going to have 1 over negative 3 squared is 9. So 1 over 9x squared would be my final answer. Number 6, I'm going to distribute that second power. So I'm going to have 5 to the second times a to the negative 8th, right? You multiply them. 5 to the second stays where it is. That's fine. That's going to become 25. It's just this a to the 8th that is an issue. That's going to come to the bottom and become positive. Right? Even if there's not a denominator there, you can create one because it's always like it's over 1 anyway. Okay, number 7. Distribute that negative first power to everything. It goes to the top, and it actually goes to everything in the bottom as well. That's something new that we haven't really looked at yet. Okay, so 2 to the negative first times a to the negative second over 3 to the negative first times x to the negative first. Okay, so now if you look at it, everything here is an issue. It's all a negative exponent. So if we start with the top, 2 to the negative first is going to come to the bottom, be 2 to the first, which is just going to stay 2. A to the negative second is going to become to the bottom and become positive. Then we deal with the denominator. 3 to the negative first will have to come up top, become positive. X to the negative first will come up top and become positive. You can write to the first power, but you do not have to. Just 3x would be totally fine. Okay? Now let's look at number 8. We distribute that negative second power to everything. Okay, so that's going to look like negative 4 in parentheses, all to the negative second, x to the negative fourth, over 3 to the negative second, c to the negative second. So then from there, everything needs to get flipped, right? This negative 4 to the negative second needs to come to the bottom. The exponent becomes positive. The number stays negative. X to the fourth goes to the bottom, becomes positive. 3 to the negative second comes up top, becomes positive. C to the negative second comes up top, becomes positive. So now I'm going to have 3 squared, which is 9, so 9c squared over negative 4 squared, which is 16, x to the fourth. And that would be our final answer. Okay, 3 more problems. So again, here, I distribute the negative first to everything. So I'm going to have negative 3 to the negative first, x to the negative second, over 2 to the negative first, x to the first. It actually flipped that and made that positive, which is nice. So now I'm going to have, if I look at this, negative 3 to the first, it's going to come to the bottom. X to the second is going to come to the bottom. Now if I look at the original denominator, 2 to the negative first will come up top. X to the first will stay where it is. It doesn't have to move anywhere because it's not negative. So then 2 over negative 3, x to the second times x to the first, add the exponents, it becomes x to the third. Number 10, 8 times 8, the bases are the same, add the exponents, that's going to be 8 to the 0, which is just 1. All right, last one, bases are the same, so this is going to be 2 to the negative fourth. Negative 7 plus 3 is negative 4. That's the same as 1 over 2 to the positive fourth, which is the same as 1 over 16. Okay? So, I know that was kind of a lot to take in. You might have a lot of questions, or this might have really clicked for you, regardless of what it is. When we meet in our live session in a little bit, you will have more than enough time to ask me questions, and we can go over any of these problems. Okay, so I'll see you guys soon.